the e-call obviously is into Northwest Fire Control. They'd relayed the information to us to give us what we're attending, and also the type of vehicle is, as we've mentioned before, has moved on a lot. So electric vehicles in particular have been, I won't say a thorny issue because they're really, really good for the environment and, it's the way forward. But it's been a prickly issue for emergency services to actually respond to effectively. And it's been a learning curve for us. So we work very closely with the information channels that are given us on, specification knowledge to inform our rescue techniques. We need to know where the safe cutting and isolation points are, especially to avoid the high power cable sections that are usually in orange cable. But I'll just read you out the 5 steps to isolating a high voltage vehicle. Just to show where this has gone. So this is for all crews attending a electrical vehicle. So number 1, turn off vehicle ignition and remove the key 5 meters from the vehicle in case it self-starts again. Disconnect the low voltage battery earth. Number 3, use crash data to locate the high voltage service plug or first responder loop. Number 4, don electrical gloves. So we carry electrical gloves up to 3,300 volts resistance. And then number 5, isolate the high voltage service plug using the one-handed method. So basically that's putting one hand behind your back with electrical gloves on, just so you take the plug out, so then it doesn't go to earth, the other hand isn't the earth, or you cut the first responder loop. So we've got to do all this, and that's just to isolate an electric vehicle before we even start carrying out extrication techniques. So it's really give us something to think about. And then when you look at the information we get on what type, is it a hybrid vehicle or is it a full EV electric vehicle, and look at the battery, the batteries that are contained within. Usually they are lithium ion batteries, and the real issue with them for us is if they're damaged, they can have what's called thermal runaway, and so basically that means they can self-heat. So even if we turn up with a truck with 1,000 litres of water on, we isolate the vehicle and then we cool the batteries to a point where we think the fire is extinguished, then because of this phenomenon of thermal runaway, the lithium ion batteries will just self-heat, and then they reignite and really reignite, so the whole car is on fire again. So we've learned from that over the last few years, and fire and rescue services have adopted the way they suppress fire. So here in Lancashire, like many other fire and rescue services, we've brought in water bowsers. So basically that's a water tank with a 9,000 litre capacity of water on board, where we would deploy along with the predetermined attendants to a major collision on a motorway, but especially if it's involving an electrical vehicle. So we've got 9,000 litres of water to suppress the vehicle fire and ensure the thermal runaway doesn't kick in and it reignites. But that's not the end of the story there. When we've kind of finished with the vehicle, we do a handover form saying that the vehicle then should be stored remote from buildings and not inside for a period of 24 hours. So the vehicle recoverers have got to take it to, should we say, a safe place where if there is a small chance of reignition, then it's not going to cause a safety issue and set fire to anything else. So with electric vehicles, first of all, knowledge of specification, type, as much information you can get for the incident, but then it's adopting your procedures to ensure you can deal with the incident in the best way and make sure it's safe in the long term.